Welcome to PM Ready, your guide to becoming PMP certified. This lesson covers both quality and risk management documents. Essentially, it's two lessons rolled into one because the number of documents for quality and risk is relatively short. But don't worry, there are quite a number of quality and risk tools and techniques. The quality documents covered in this lesson include the Quality Management Plan, which is part of the Project Management Plan, as well as other quality-related project documents, including quality metrics, quality control measurements, and the quality report. The Quality Management Plan describes how applicable policies, procedures, and guidelines will be implemented to achieve the quality objectives. Notice the careful wording here. Using the word applicable suggests that there are quality policies, procedures, guidelines, and standards out there that you should be using. Many of your quality standards will come from your organization or from your industry. You will need to make sure that you consult with these resources in order to come up with a good quality management plan. The quality management plan should also include the activities and resources that you need to carry out your quality management on your project. And as with all of the other management plans, it should be tailored to meet your project's needs. It can be formal or informal, detailed or broadly framed, depending on the needs of your organization and project. The benefits of your quality management plan include having a better understanding of the value of the project. Better quality can reduce your costs, and you can deliver faster and stay on schedule better with a good quality management plan. Suppose you're managing a software development project, and you need to decide how you're going to do quality management on this project. Are you going to have a dedicated QA team that does testing and follow a more traditional approach where programmers do their coding, and then when they're done, they throw it over the wall, if you will, and the testers then test it and then give the results back to the programmers? It would be better if you specify specific criteria for handing the code over to QA. For example, you may specify that it has to be peer-reviewed at least. You may specify that it needs to properly build and run, and that unit tests have been run before it's given to QA. You might even follow test-driven development, in which you define the tests for your components before you actually write the components. And then the developers or automated systems can run those tests on those components before you even give it to QA. Or better yet, you could introduce automated tests. It isn't necessarily feasible to automate everything and all of your tests, but some organizations have found great value in automating the main, most critical paths, like for e-commerce, the path of shopping, checking things into the cart, and checking out. This can all be automated so that when new components are developed, these main paths can be checked in an automated way very quickly, in a matter of minutes. Your quality management may also include how you hand over your project into operations. How do you integrate a new software program into the existing environment and do that in a quality way? One of the most basic and primitive ways is to make the developers responsible for everything. The philosophy here makes some sense in that you want the developers to take responsibility for what they do and to take ownership of their code and the quality of their code, and that if it doesn't work, they're the ones that have to support it and make sure that they fix it if there are any problems. However, experience has shown that this doesn't often work as well as you would think. It's usually better to separate your development and support. There are several reasons for this. One is that support and development people have different personalities and different approaches to their work that don't often meld together very well in single individuals. It's also valuable to keep these responsibilities compartmentalized. All too often, when a developer has responsibility to put something into its production environment and to support it, they feel that if they put something in there that doesn't quite work, that they can kind of fix it in place and get it working. This causes the support and service of this application to suffer. When developers are in charge of the production environments, they tend to do things that make the environment less stable and to experiment and do their work in the production environment, which affects your users. It's usually better to keep this separate and to have the developers work closely with support and follow clear quality rules to make sure that whatever gets put into production works well, and that if it doesn't, you roll back very quickly in order to minimize any impact on your users. These are the kinds of quality concerns that you should consider and address and specify in your quality management plan. Here is an outline of what your quality management plan should probably contain. It should list the quality standards that will be used by the project. For example, suppose you're developing software for the government, in which case you may well need to be Section 508 compliant, which means that your software needs to be compatible with all of the rules and requirements for your software to be more accessible to people with disabilities. You should also include any specific quality objectives that you have for your project. You may have a requirement that certain screens on your system load within a certain time frame, or that certain reports have to be generated within a certain number of seconds. You may also have certain data quality requirements, such as how often data is synchronized between different systems. In addition, data quality checks may need to be specified. I'm sure that you have seen examples on websites where as you're entering information into the system, it checks to make sure that what you're entering in is formatted correctly, such as email addresses that look like email addresses, zip codes that look like zip codes, drop-down lists for different states or provinces. You may also have seen examples in which you type in your address and a service is used to check your address against the database of addresses in the postal system to make sure that the address is valid and to suggest alternative forms of this address that are more standard. You should also specify the quality roles and responsibilities on the project. Who is responsible for quality? Everyone? Yes and no. If everyone's responsible for quality equally, turns out that no one's responsible for quality, and it doesn't get done. What you need is a combination. You need to have a leader, a champion of sorts, someone who is an expert, someone who can consult with or be on the team, who is focused on quality and the expert in quality. But then you also need everyone on the team to take responsibility for quality, for following the quality plan and the procedures, using the tools and suggested improvements, and all of the suggestions and guidance provided by your quality champion or leader. You should also define which project deliverables and processes are subject to quality review. This answers the question of what will be quality checked. If you're doing software development, are you going to quality check the code? Probably. Are you also quality checking your build scripts? Or even your code repository? Your plan should define which quality control and quality management activities you have planned, and which tools you'll be using for the project. In the case of software development, what kinds of activities will you be doing to check quality? Peer reviews? Will you also be checking your production performance? Will you be doing stress and load testing of your system? How about failure mode testing? Is your production environment set up for cold, warm, or hot failover? And have you tested those to see how well they actually work? Do you have a disaster recovery plan? And if so, how do you test it? And how often? What tools will you be using for your quality checks? Do you have automated testing tools? Configuration management tools? Build tools? What are they? How will they be used? And finally, you should define those procedures that you'll be following to deal with nonconformance, corrective actions, and continuous improvement. You need to answer questions such as, how will quality data be analyzed, summarized, reported, and then communicated? How will you be doing continuous improvement? Will you be doing retrospectives? What other techniques will you use? And how do you fix failures? Do you fix them in place in the production environment, or will you have a proper rollback plan? Will you be doing root cause analysis, and what tools and techniques will you be using for that? Your quality management plan should also include the quality metrics that you will use on the project. A quality metric specifically describes an attribute of your project and how the control quality process will verify compliance to it. Quality metrics include such things as the percentage of tasks completed on time. Notice that this is one that is specific to project management more so than the product itself. It could include the failure rate, the number of defects that you identify each day. For IT systems, the total downtime per month, or the number of errors found per 1,000 lines of code. It can also include your customer satisfaction scores, the testing coverage that you have in testing your system, and of course, how long it takes for web pages to load. These are just a few examples of quality metrics that you can include on your project. Quality control measurements are those measurements that you take during the control quality process according to the quality metrics that you specified in your quality management plan. If you have a metric, such as the number of defects found per day, then you could measure that every day, and those measurements could be Monday you found 2, Tuesday 1, Wednesday there were none, Thursday you found 2, and Friday you found 3. Those 5 measurements are examples of quality control measurements that follow this metric of the number of defects found per day. It's important that you distinguish between metrics and measurements. Metrics are the rules for what you're going to measure and how, and the measurement is the actual measurement that you take following those rules. A metric specifically describes a project or product attribute and how you're going to measure it, whereas a measurement is the measurement taken as specified by that metric. For example, you may want to measure customer satisfaction, and as part of the metric, you'll specify that you'll do this by sending out an email survey after each time that you provide a customer service. And you could specify that you want your customers to rate how satisfied they are using a scale of 1 to 4. The measurement of customer satisfaction would be that score, which might be 3.7. Your quality report, which you'll send out periodically, should include a summary of your findings from your control quality process. It should include those measurements that you've been taking and identify any quality management issues that you've found. It should provide recommendations for corrective actions, as well as recommendations for any process or product or project improvements. And this is the end of the lesson on documents related to quality management. These documents that we've covered include the quality management plan, the quality metrics which specify what to measure and how to measure it, the quality control measurements, which are those specific measurements that you take based on or specified by the quality metrics, and your quality report, in which you report on the summary of your control quality findings and report on issues and provide recommendations. And now we switch gears to talk about the risk management documents. These include the risk management plan, the risk breakdown structure, the probability and impact matrix, the risk register, the risk report, and the issue log. The risk management plan describes how risk management activities will be structured and performed. Notice how proactive this statement is. The PMBOK guide defines risk a little differently than you're used to. It defines it as uncertain events or conditions that, if they occur, have a positive or negative effect on one or more project objectives. Normally we're used to talking about negative risks, things that threaten the project. But the PMBOK guide also includes positive risks or opportunities that you can exploit or enhance to improve your project. These are combined because managing them uses the same basic analysis and tools. The PMBOK guide also differentiates between overall project risk and individual project risks. As you would expect, individual project risks are uncertain events or conditions that, if they occur, have a positive or negative effect on one or more project objectives. Overall project risk, however, is the effect of uncertainty on the project as a whole, arising from all sources of uncertainty, including individual risks, both positive and negative. Overall project risk includes, or is a sum, if you will, of all of the individual project risks, but also includes other sources of uncertainty. These can include things like your uncertainty or range in your estimates of duration and cost, and can include uncertainty about the resources, their availability, and their skill sets, and their level of productivity. Your risk management plan should contain your overall general approach to managing risk, or your risk strategy. It should also identify the methodologies or specific approaches and tools and sources of data that you'll use in managing risk. It should identify and define the roles and responsibilities when it comes to managing risk, who's going to lead this effort, who will support it, and how. It should also specify the funds that you'll need to manage risk and the rules for the use of those funds. The timing of when risk activities will be done and how often. It'll also identify risk categories, and these can be represented in a risk breakdown structure. Should specify the stakeholder risk appetite. Are your stakeholders risk averse or risk tolerant, and how much? Definitions for risk probability and impacts, and specify a probability and impact matrix. It should also tell you or define what formats you're going to use for your reports, including your risk register and your risk report, and the procedures for recording and auditing activities related to risk management. Your risk breakdown structure is simply a hierarchical organization of your project risks organized by categories. This may be provided by your organization, or you may need to come up with it on your own. Your project's risk register is where you record all of the details of all of the individual project risks that you've identified, and this will be updated throughout the project. The risks in your risk register should contain a unique ID, a name, and a description. Each risk should be prioritized. Each risk needs to have a risk owner assigned. This is critical. You need to have someone accountable for that risk and how it's managed. For each risk, it should also identify the root causes, the risk triggers, and the warning signs. It should also define the risk responses that you've chosen for each risk, any contingency reserve that is needed for that risk, and the plans and triggers for how that contingency reserve will be used. It may also include fallback plans, just in case your response plan doesn't work out. It should also identify what the residual risks are. Once you have identified certain actions to take and you've reduced this risk, how much risk is left? It should also identify secondary risks, which are risks that are caused by your risk activities. And also a watch list. These are risks that are not actively managed, but they've been identified, but because they're low priority, you don't have a response planned, but you still want to keep an eye on them, and you may want to have some contingency reserves assigned to them. The issue log is not the same as your risk register, but it is an important complement to it. The issue log is where you record problems or gaps or issues that come up during the course of the project. An issue is defined as any current condition or situation that may have an impact on the project objectives. Examples include if a deliverable doesn't meet your quality requirements, or you have a lack of resources, or there are delays in getting the materials you need, or the materials are of a grade that is too low, or very commonly, you may have communication issues or stakeholder engagement issues that come up. All of these are recorded in the issue log. Some important information to record in your issue log include, for each issue, the type of issue, who raised it and when, a description of it, the priority so you can prioritize the handling of issues, very importantly, an owner, someone who will be accountable for managing this issue and resolving it, a target resolution date, the status of the issue currently, and once it's resolved, what the final solution was. Your risk report presents information on the sources of overall project risk. It may also include some summary information or aggregate reporting on identified individual project risks. And of course, this is updated throughout the project. Your risk report should focus on overall project risk, including a summary and current status of the project risk, as well as any recommended responses and expected results based on those responses. Should also identify the key sources of project risk and which are the most important drivers of risk, those response strategies that you've agreed to, and as risk audits are done, the conclusions of those risk audits should be included as well. Although your risk report should focus primarily on the overall project risk, it can also include some summary information on individual project risks that you've identified, including, for example, the number of threats and opportunities you've identified, the distribution of those risks across different risk categories, and any metrics or trends that you have to report on the aggregate information about these project risks. And that wraps up our overview of the risk management documents, including the risk management plan, the risk register where you record all of the details of your identified risks, the risk breakdown structure, which allows you to visually organize all of the risks into different categories, the probability and impact matrix, which is the assessment of individual risks, the risk report, which provides a report of overall risk, and some aggregate information can also be included regarding individual project risks, and the issue log, where you record and manage the unexpected events that come up. For more information about quality and risk management documents, you can consult these pages in the PMBOK guide. PM Ready is a publication of PM Guaranteed and is based on the Project Management Institute's PMBOK guide.